So in this lecture, we are going to discuss about Taguchi's concept of quality, codes, and standards. So Taguchi's key concept and contributions to quality theory. So I'm going to explain the particular concept called Taguchi concept of quality, and he is given some theory about how he has contributed to quantify quality aspect, okay, in construction and in general, okay, manufacturing sector or any sector. So Taguchi has developed an approach to quality that places emphasis upon product design. Okay, so it's more emphasis is given to product design stage. The cornerstone of this approach is robust design achieved through the methodical prototype reduction of variance in the product. So put another way, Taguchi seeks reduction in variances of accepted and tolerated in the production of unit or item. So to Taguchi, the tolerance of acceptable item variance in a manufactured product results in what he described as loss function. Okay, so he is describing a term called loss function. Okay, so the loss function means the particular you know product which comes under the loss function means it is acceptable variance. Okay, it is all acceptable variance. Whatever is coming out of this loss function, it is not accepted. Okay. For Taguchi, any variance from the exact product specification results in what he terms like quality loss, even though the product may still be within the traditionally acceptable level of variance. So traditionally, product components failing within the level of acceptable variance would be considered to be usable. The Taguchi views this as an unacceptable in quality terms. As a failure of product component to be exactly to target specification, which facilitate the customer dissatisfaction as a product may perform below its designated optimum. Okay, so this could result in customer return of the product, customer refusal to purchase another product from the acquisition, customer advising others not to purchase that product. So this is all the things that could happen whenever the particular product is not meeting the required designated performance. Okay, so this customer dissatisfaction will happen. That is why Taguchi is giving some objection to this particular concept. Okay, so the Taguchi clearly identifies the possibility of customer dissatisfaction with a product that is traditionally within the tolerable levels of variance. So you can see in the diagram that is the line this one shows it is a product component size. Okay, so this is the product component size. So this is the product specification. Okay, this is a product specification. So this level, the dotted lines, it is specified as traditionally acceptable tolerance level of variance. So this is what we can say it is a traditionally accepted. The product, if it is placed in anywhere, it is found to be acceptable. Okay, so it is if it is placed in anywhere, then it is acceptable. But what they are saying is this is the product specification. It has to meet this function, and this particular level line that Taguchi is defining as loss function, which occurs with tolerated acceptable variance. So it just uh, defining in some other terms called loss function. Yeah, okay. So the Taguchi provides a quadratic formula for the loss function. This being that is L equal to C into x minus t whole square plus k. This is the function is giving in terms of formula. So H stands for quality characteristics, T stands for specific target, C stands for cost of failing to meet the target. Okay, the total cost. K is the minimum loss to the society. Okay. So the formula indicates that the product's variation for the specified component target doubles the quality losses quadrupled. Dissatisfaction in the loss is exponential to distance from the specified quality target. Okay, so the Taguchi approach to quality and reduction of the loss function emphasizes the need for optimization of product process prior to manufacturing. He provides the methodology for the design of product test prior to commencing any manufacturing. Okay, we need to make sure the product is giving proper inspection before manufacturing in a bulk lot. Okay. As such, this approach is not one grounded in the pursuit of quality through inspection. Instead, this developed approach is one of employing offline quality control. In pushing quality control back to design stage, Taguchi's methodology advocates the use of prototyping and experimental studies. An experimental design procedure is prescribed for use within the design stage. This procedure provides for the efficient and effective carrying out of simulation experiments with the use of orthogonal arrays to enable the study of simultaneous effect of several production process parameters and their interaction. So reduction of quality loss is achieved via the deployment of three-stage prototyping methodology to the product manufacturing design process. So the three stages are system design, parameter design, and tolerance design. So the system design for both process and product. Okay. So the parameter design is to investigate the optimal combination of process and product parameters. This is done with the objective of reducing sensibility, that is, variance and loss factor, in production. Tolerance design, it identifies the sensitive components of the design that may be give rise to variance in production. So alternatives are considered and tolerance limits are established. So in different stages, they are given different, uh, uh, you know, criteria for process and product parameters. Okay. So by exercising the quality control throughout the product manufacturing design stages, the Taguchi's method aims to identify and reduce variance causing noise factors within the production process and optimize production control factors. So this is what the Taguchi's method is trying to reflect. That is, only thing is you have to identify and reduce the variance causing factors within the production process, and we have to at the same time optimum the production control factors. Okay, so this is a reference referred for preparing this lecture. Thank you.